Okay, now we move on to alkynes. So alkenes had a double bond, alkynes have a triple bond. So let's do some naming. Heptyne looks a lot like heptane. 7 carbons, 7-carbon chain, and then we have a triple bond at site 2. Now I'm going to change the structure. I just want to do this out first in this form, and then 1, 2, 3, 4 iodo, 5 ethyl. Now this triple bond, now that we've created that triple bond, has a 180-degree angle, so we should draw it like this. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5. There shouldn't be any angle to that. Now on the exam, since you have to draw this out, I'm not going to cry if you do this, and I'm not going to be mad if you leave it with this angle. But you should know that really the way you want to draw the structures is like this one here, where you can see that I've made this. There's a carbon here, and it should be considered a 180-degree angle. And in more advanced courses, they're going to be real sticklers about that. And this also adds to adds to our rules about carbons. When you go from a single to another type of bonding, there's a carbon at either end of this new type of bonding. We had it for terminal carbons, one's on the end, one's at the kinks, one's at intersections, and then also here where you change the bonding, that's a new carbon as well. Okay, so just be careful with that. This I'll accept on the exam because I know that you're writing it. Once you write it, then you'd have to redraw it, but you want to keep that in mind for later classes. Okay, so I think that's the guy. Let me make sure. 1, 2, 3, 4, 5, 6, 7. 1, 2, 4, 5. Okay. Now for this guy, let me put circles on all the carbons. And we can see that we start the triple bond, just like the double bond, we have the same, it's almost the same exact rules, except that instead of E-N-E, we end the compound with Y-N-E, yne. So that's going to be an octyne. Then we have 1, 2, 3, 4. We got a lot of fluoros, so this is going to be 4, 4, 6 trifluoro. We have 2 methyl groups, a 5 and a 7, so 5, 7 dimethyl. 1, 2, so 2 octyne. And again, and we could also have, the other naming would be end in, it would be all of this, then dimethyl oct2yne, or oct2yne. Won't worry about that, just know that it does exist. This one is a weird looking one, and I put it in here on purpose because I wanted you to see. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have the triple bond will be on the end here. And we have, so this be 1, 2, 3, 4, 5, 6, 7, 8 chloro, 8 chloro, 9 chloro, 9 chloro, and then chloros on each of the all the ends here. The reason I created this one is because you see all the chlorines are right down at the end here. They're really bunched up at the end. Here's the last carbon. But the numbering starts here because the triple bond takes precedence over all of this. There's nothing here. It looks like you'd really want to start on this end, and if it was an alkane, absolutely. But that alkyne, you have to start the numbering down here. This is carbon 1, this is carbon 2, all the way down. And I should also mention that the structure should really be 180 degrees, so it should be like that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then chloro, 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 chloro. So even though I draw it like this because you start out with the regular alkane kind of kinked up chain, this is the true structure. And then we have this guy. We look for the longest parent chain. The parent chain has to be the longest chain that contains the triple bond. You can't leave it off. Even if you can find a chain that's longer but doesn't contain the triple bond, that's a no-go. You have to have the triple bond in here. So 1, 2, 3, 4, 5, 6. So that's hexyne. We start numbering from this side, and then we put everything else on. There's 2 ethyl groups here, so I'm on the page. So 3, 4 diethyl, and then 1 hexyne. And again, students make that mistake. This will be one. They'll go through this whole process, and it's 3, 4 diethyl, 1 hexane. It's not hexane, and I know that you know that, but it has to be done that correctly on the exam. Okay, now since the naming of alkynes is essentially the same as alkenes, I think that's as far as we have to go with the practice. In organic text, the full-blown 200-level organic textbook, I used to try to go to those for examples. But what they will do is they'll name the alkanes. They'll do about 5 or 6, and then the alkenes and alkynes, they'll name some alkenes, and they'll say the alkynes are just like that. So you don't get a lot of information there, but that shows you how close the rules are. In the advanced text, they just say, well, if you know how to label or name alkenes, you know how to label alkynes, and that's true. The name alkynes. Okay, so draw 6 isomers with the same formula as 3 hexyne. I'm going to make this 4, just I think that'll be enough. So hexyne, let's draw it out first. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I want 1, 2, 3, so triple bond there. And I'm going to rewrite it in this form. So this will be boom, 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 boom. 1, 2, 3, 4, 5, 6. Just so that we have the correct orientation here, the correct angles. Make sure we got everything here. 1, 2, 3, 4, 5, 6. Okay, and then we can take the triple bond. This is what we're starting with. And we can put the triple bond here. That's 1, 2, 3, 4, 5, 6. We can move it in 1, 2, 3, 1, 2, 3, 4, 5, 6. It's that getting that 180 degrees. It's tricky, but we got to keep that in mind. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. On my exams, I'll let you just build up from the alkane, and I'm not going to sweat it, but if someone else is teaching this course and using these videos, you want to make sure that you know what they want. They want that, if they want those bond angles, that's what you have to give them. And then we already had the one in the middle here. 1, 2, 3. And so we can go back to this guy. 1, 2, 3, 4, 5. There's another one. And then we could 1, 2, 3, 4, 5, put there. And we have a lot more to play with. We could have easily found 6. Now that I look at it, we could have probably find a few more than that, but I think that'll do. Name the 3 physical properties of alkynes. What could they be? Insoluble, insoluble in water. In water. Lower density than water. BP increases with increase in molecular mass. And I'm really abbreviating this because I don't know, this is the 3rd time I've written this, 4th. And then we have soluble in nonpolar solvents. So a lot of the same stuff over and over. If you've been paying attention in the previous lectures, this should really be very familiar. It shouldn't be anything that catches you off guard. And that's why you want to make sure you know the previous stuff before you move on. Okay, this one here. Now you have a triple bond. And so if you have just bromine here, it would break one of the bonds. 2 bromines are needed to break all of them. I should say the 2 extra bonds here in the triple bond. So we end up with bromine being added here, and then here, and then we get the rest of the structure. This, boom, 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 boom. Make sure. So for a double bond, we just need 1 bromine molecule to add across. Triple bond, we need 2. And then for this one, it's hydrogen, so we need a catalyst. nickel or platinum. You can even write catalyst if you wanted, but you have to indicate that there is a catalyst that's necessary. They don't state that for the halogen, so you don't need any. So let me rewrite this guy here. And then, actually, this would just be, so where are we here? We have this, 1, 2, 3. We could just leave it like that, because we've just added the hydrogens across. So, or we could put in all of the, could show all the hydrogens if you wanted as well. So, yep, that would be it. And I want to finish up a thought here. We have, let me just write out something like this. And what if we just added one hydrogen across? So we have a nickel. Then we'd have a double bond, and we'd have one hydrogen above, one hydrogen below. We'd only have broken one of these bonds. So if you want to break the two of them, so now it's a single bond, you need to add two hydrogens. So if you only have one hydrogen will allow you to go from an alkyne to an alkene. If you want to break an alkyne down to an alkane, you have to add two hydrogens.